Okay, we're in section 106 now. As always, contents, examples, and exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF document you're looking at here is being made available to the Prison Mathematics Project participants only. I realize there may be students and teachers watching these videos that are interested in getting a copy of this document. If you are, please email me and I'll let you know when it's going to get published. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right? So let's just tell you what your responsibilities are. Your responsibilities are to read the contents. Like I always say, reading mathematics is something that's essential. It's also incredibly difficult at times. They do go through some examples. I basically go through the same examples, but with slightly different way of explaining to people. Right? I can't say it's substantially different because it's really the same story over and over again. But anyway, let's take a look at this one over here. And what we're trying to do is, let's take a look. Oh, this is a good quote before I forget. A person who won't read has no advantage over one who can't. A surprising number of people can read, but don't read. All right, they don't read. They're not illiterate, but they can read. They're not illiterate. It's unfortunate, though. I think the word for that is illiterate. Anyway, let's get back to the story over here. Find the probability of throwing 4 in a single throw of 2 dice. So I want to point out what they're doing. They're throwing 2 dice down. Right, and there's a ton of outcomes over here. I shouldn't say a ton, there's really not a ton. There's 6 choices for this one. The dice have 6 faces, and 6 choices. So the total choice, total outcomes, is going to be 6 times 6, which is 36. Let me try to make that a little bit neater. So total outcomes. There's 36, which is 6 times 6 equals 36. Remember what I'm saying? The faces that are showing, there's 6 sides to each cube. There'll be 6 outcomes for each dice. 6 times 6 is 36. But what do they want? They want to know the chance of throwing a 4. So for me to get a 4, I could have a 1 and a 3 here. Not even sure what the dice look like. That doesn't look right. I'll put the numbers down. So I'm going to say it could be a 1 in this die, a 3 on this die. Or it could have been a 3 on this die, a 1 in that die. Or it could have been a 2 and a 2. There is no other outcome that would give me a 4. And how many are there? There's 3. So the total number of successes, that's a success. The success is the total number, that's going to be 3 cases. So it's going to be 3 out of 36, which is going to be 1 in 12. There's a 1 in 12 chance it's going to happen. All right, 1 in 12. Let's go to another one. There's a bag. It contains 4 $10 gold pieces. So I'll put the bag down over here. And there's how many gold pieces? There are 4. I'll put this over it. G, 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 and G. And these are kind of mixed up in the bag. You're not seeing what's in the bag. All right. And how many silver dollar pieces are there? There's 6 of them. So I'll put S, 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 S. So what do they want you to do? They have a bag that contains this. They want a person to draw 2 coins at random from the bag. So I'm going to say they put their hand in the bag. The coins are indistinguishable from their feel, and you're going to pick 2 out. So how many totals are there? And again, the order in which you pick them out doesn't matter. Whether you pick out, a gold, or a gold, silver, or a silver, gold, or a silver, silver. I'm going to say there's 1 case over there, only 1 case for that as well, and 1 case for sorry. So I'm not really worried about the order of them coming out. I'm worried about what they are. So let's talk about that. All right. So let's talk about the picking of the 2 gold pieces. All right. So the probability of picking out the G. All right? And let's talk about that. Well, let's take a look. So I'm going to say, how many, you're picking 2, right? And the order doesn't matter. It's combinatorial. How many in the bag? There's 10, right? And you pick 2. Now, from the gold pieces, how many gold pieces are there? There's 4, and you're picking 2. And how about from the silver? Well, there's 6, but you're picking 0. I'll compute that later, right? So that's and again, we'll get back to the expectation later, right? The probability, let's take a look at this one over here. I guess I want to do gold. We pick 1 gold and 1 silver. Again, it doesn't matter if it's gold, silver, silver, gold. It doesn't matter. And I need a little more room, so I'm going to erase this over here, and I'll put it somewhere else. The probability of gold, silver. Well, there's still 10 things in the bag, and I'm going to grab 2 from the bag. From the gold coins, which are 4, I pick 1. And from the silver coins, which 6 coins, I'm picking 1. I got that over there. And we'll compute that a little later. What's the other one going to be? The probability of a silver. Well, there's still 10 coins. I pick 2. Of the 4 gold coins, I pick 0. And of the 6 silver coins, I pick 2. Now, I got some computations to do over here, right? Let's do one at a time. And I'm going to do the bottom, because the bottom has to be done each time. So it's going to be 10 factorial, 2 factorial, 8 factorial. And what do you get there? You get 45. So every single time, I get 45 outcomes in the bottom. All right, let's keep going. 4, 2. That's 4 factorial. Just doing some arithmetic on the side. 2 factorial, 2 factorial. And let's see, that's 4 times 3 over 2. That's 6. All right, we'll talk about what that means later. By the way, 6 zeros 1. That's 6 factorial, 0 factorial, 6 factorial. All right, let me get my eraser out. I don't need to see the arithmetic over here. I don't see the need to arithmetic over there anymore. And I got to do something else now, don't I? I have to do 4, 1. Again, if you do this, please do it in your head. 4, 1, 4 factorial, 1 factorial, 3 factorial. That'll just be 4. And 6, 1 is 6 factorial, 1 factorial, 5 factorial, which is 6. So it's going to be 24 over 45. All right? So let's do the next one, silver. Let me get my eraser out. Again, if you quicken this, please do it quickly. 4, 0 is 4 factorial, 0 factorial, 4 factorial, which is 1. And let's do 6, 2 now. That's going to be 6 factorial, 2 factorial, 4 factorial. Well, that's 6 times 5 over 2 times 1, which is going to be 15. All right? So I want to just go up here and say all my chicken scratch. I want to make sure that I got at least that part right. So gold, I said was 6 over 45. Some people say, why aren't you reducing them? Well, we can. I'm just going to 6 out of 45. The chances of getting a gold-silver choice would be 24 out of 45. I see that here. Again, that's written over here as well. 4 times 6 is 24. And 1 times 15 is 15, so we get silver. But what they said, which for a lot of students are looking at this, I didn't even know what they were talking about when they said the expectation. Well, I hope you realize these are the choices. These are the outcomes. Now, if you added all those together, what would you get? 6 and 24 is 30, and 30 and 15 is 45. So this really is just a 100% chance this is going to happen. All right, 100% chance. But what they're not asking that. What they're asking for is that, what's your expectation? How much money are you going to make? Well, 6 times out of 45, right? This guy over here. 6 times out of 45, you're getting 2 gold coins. What are 2 gold coins worth? Well, they're worth $10 each. So 6 times out of 25, you're going to be making 20 bucks. And we'll talk about expectation later. Gold, silver, what are you going to be making? Well, gold, silver would be 10 and 6, $16. Now, if you're just getting the silver coins, that's worth $12. All right? Let's talk about the expectation. 6 times out of 45. You'd be expected to make $20. 24 out of 45. You'd be expected to make $16. Let's keep going. 15 out of 45. You'd expect to make $12. Now, I want to go through the arithmetic, which for some people, they say, do I need to do arithmetic? Yeah, you really do, right? And when I do it, it may look different than what you would do, but I don't think it's that bad. All right, I'm going to do this. What's 6 times 20? It's, by the way, the denominator is nice, it's 45. Yes, you can reduce it if you want. So I'm going to say 6 times 20 is 120. All right, I just did this part here. I'm going to do this one now. Well, 12 times 15 is going to be 180. And 24 times 16, I'm setting it aside for you. That's 240. 10 times 24 is 240. Well, let's see, 6 times 20 is 120. And 6 times 4 is 24. 384. Did I make a mistake somewhere? I think I did. Oh, you know what I did? I wrote the wrong number down. I got to change what I'm doing, and I apologize. So I made a mistake. I made a mistake in the value. I was saying the silver pieces were worth $6. I misread, so I got mistakes made. I got to erase this over here. This is a mistake. That's not a mistake, but I'm going to say I got to read again. And I apologize for misreading it. This is $20. And the other one is back then, $10 gold pieces and silver dollars are worth $1 each. This is going to be $11. Sorry about that. And actually, when I was doing it, I was saying that, gee, the silver was really expensive, because if it was $6 and the gold's only 10, I was expecting much difference in that. By the way, the price of metals does vary a great deal. Silver would be $2. All right, sorry about that. So 6 times out of 45, it'll make the arithmetic a lot easier for me, times 20, plus 24 out of 45, you'd make $11, and 15 out of 45 times, you'd make $2. All right, what's the expectation over here? Well, let's write this down. I think I did it before. I got to erase my nonsense over here. We have a key to match, don't worry. That's going to be 120. That's 240 and 24, 264. Much easier numbers than 30, right? I got to add that together. Let's see, 260, 360, 384. And then I have to add 30. So 414, right? Over 45. By the way, if you told someone you made 414 over 45, or you expected to make 414 over 45, they'd have no idea what you're talking about. So I want to just emphasize that. I think it might be in your interest to do some arithmetic over here. All right, so I'm looking at 414 and 45 and 4, 5, 6, 7, 8, 9. Oh, I know they're divisible by 3. I know that much. And so how do you know that? If you add the digits together and they divide by 3, the number divides by 3. So I'm going to reduce it by 3. So 414 over 45 divided by 3. Well, the bottom's easy. That's just 15. let me do 4 into 4, 1, 4. And that goes once, 3, 1, 1. That goes in 3. 3 times 3 is 9. Then you get 24. And 3 goes in 24 8 times. So 138. Oh, that's with that 3 again. So 3 goes into 5, 15 5 times. And 3 goes into 138. Let's see, 4. That would be 12, right? 18 and 6. 46 times. This is easier for me to do. Let me get my chicken scratch, get rid of it. And I really want to get money out of this. And what am I noticing? I multiply both top and bottom by 2. So 46 over 5 would be 10. You may wonder why this makes it easier for me to divide by. That would be 92, right? And what's 92 divided by 10? 9.2. Now someone says, what does 9.2 mean? Well, it's money. My expectation, if I pick 2 coins at random from a bag that contains these coins of those values, it would be $9.20. That's my expectation. What's the best I could do is 20. What's the worst I could do is $2. You get the idea. So the expectation is $9.20. All right? So I think that's it, and it is. This is, again, a tough section. The reason being probability and counting is always tough. Everyone finds it difficult, even those people that are expert at it. Right? So my understanding is go through the exercises. I do put a little work down there for you. And, you know, I would say that you work through it and try and struggle. Right? Could I have made an error? Of course I could have made an error. What are you doing? You're struggling through this stuff. 5, 6, and there's quite a few problems to struggle through. And some problems I do more work than others, by the way. And I hope you're willing to do that work as well. After you finish the work, and you do have access to a computer, I would recommend you do the SAGE, just to look at it. What's SAGE? Computer Algebra System, or CAS for short. It's open source. You can go to this website, download it, or just use the interactive web application, and you could see me doing some arithmetic over here if you like. What are we doing over here, though? My claim over here is what you're really doing is you're doing the problem set as Wells intended. If you think I'm making any errors, I strongly recommend you reach out to me at this email address, and you let me know you're in section 106.3. And let's say, for example, you say there's something wrong with number 8. Tell me you're in section 106.3. Tell me there's a problem with number 8, or whatever else you think. Explain yourself. I'll certainly look at my work. Do I make mistakes? You're not kidding, I make mistakes. And if you find a mistake, I'll be more than happy to correct it and give you credit for it. Thanks again.